use of the energy conservation equation. Yeah, one. So your task tonight is to practice the sum using conservation of energy. So you and I are gonna do conservation of momentum. Yeah, so mass 1 is 0.3 kilograms, correct? Mass of ball 1, yeah. And what's the initial velocity of ball 1? It's 0 meters per second. What's the initial velocity of ball 2? And that's the direction we assumed as positive, right? Let's rather, because it's moving towards the left. That was, at least that's what's in the sketch. So we'll take to the left as positive, the direction that the ball. In the initial, 2.4, is moving to the left, yes. All right, and then what's the final velocity of ball 1? The final velocity is not 0. Remember, it's the one we have to find. But then earlier on you said that after collision, ball 1 is stationary and ball 2 continues in an unknown direction. No. The mass of each ball is 0.3 kilograms, yes? After the balls collide elastically, ball 2, which was moving toward the first ball, stops and ball 1 moves off. So what's the final velocity of ball 1? We need to figure it out, I don't know. Yes, that's the one we need to figure out. That's correct. But don't say, I don't know, just rather say the first part. Yeah, we need to figure it out. And then you leave it at that. Then, what's the final velocity of ball 2? It's not, yes, that's correct. So, and that we know that because we're told that it stops, yes? Yeah. All right. So then we can use the momentum conservation equation. So initial momentum is the same as final momentum, and our initial momentum is VI1 M1 plus VI2 M2, and that equals M1 VF1 plus the mass of the second object times the final velocity of the second object. Yeah, and then yeah, it's the mass of the first object times the velocity of the first object plus the mass of the second object times the velocity of the second object. And those two added together equal the mass of the first object times its final velocity plus the mass of the second object times its final velocity. And now substituting, we have 0.3 kilograms multiplied by 0 meters per second plus 0.3 kilograms times plus 2 meters per second, since we said that direction is positive anyway. And that equals, the first mass is 0.3, or rather mass of object 1. Its final velocity is the one you said we need to figure it out. Then you add the mass of the second object, which is 0.3 kilograms times the final velocity, which is 0 meters per second. All right. Yeah, so we've got 15 minutes to finish off this sum and maybe have like a closing off chat. So yeah, the first momentum is 0. The second momentum is 0.6 kilogram meters per second. It is 0.6, right? And the first momentum
by meters per second, 0.6.
Yeah, and then we have 0.3 kilograms times v f1, velocity final for the first object. And then the final momentum for the second object is 0. That leaves us with 0.6 divided by 0.6 kilogram meters per second divided by 0.3 kilograms. Therefore, the final velocity of object 1, which is billiard ball 1, which is now moving, is 2 meters per second in the same direction that the first ball was moving in. So now you check using the kinetic energy equation whether or not you'll get 2 meters per second. Ne? Will you do that for us? Yeah, you'll do that for us, right? All right. Okay. So it's about time up. Yeah, so just go over your classroom with content. Videos will be uploading progressively. And then please go over the same theory that we go through so that you build the necessary, I guess, memory to understand these even just by looking at them next time. And if you want tips on how to apply the conservation of energy equation, you can refer to page 48. Just make a note of that. Page 48. Like, I cannot emphasize it enough. If you're going to write the exam, you need to practice. No amount of video watching will get you to pass it. So you need to actually do the problem, but you'll start seeing the videos. For now, I would encourage, do go over the problems, challenge yourself, push yourself. You know, some days you might feel motivated, some days not, but when you do feel motivated, do go beyond your comfort zone, do interrogate your answers, do check if you are guessing or if you are applying the correct method, so that you grow your confidence in actually applying the correct method. because that shows you understand the concept.
Okay.
Wanetwamos.
Thank you for having the classwork with me.
All right. So I'll see you when? Will I see you Thursday for
Yes,
Thursday for science? But
Thursday.
I'm hoping, I'm crossing thumbs to not have load shedding